Now that we have learned about the definition of the 6 trig functions, we can start to introduce identities of the trig functions. So we have 3 basic identities, and they're called the reciprocal identities, the quotient identities, and the Pythagorean identities. So let's begin with the reciprocal ones. The reciprocal identities are just by definition. And so it's kind of how I ended the last video, which is if we have the ratio A over B, and then we have the ratio B over A, these are called reciprocal of each other, because the top and the bottom switch. So let's write the definition of them one more time. Sine of theta was B over C. Cosine of theta was A over C. Tangent of theta was B over A. The cosecant of theta was C over B. The secant of theta was C over A. And the cotangent of theta are A over B. And I positioned them this way on purpose because I'm putting the reciprocals right next to each other. So sine and cosecant are reciprocals, cosine and secant, and tangent and cotangent. So how you write the reciprocal identities is that the sine of theta will be 1 over the cosecant, because when you put 1 over, that means you're going to switch the top and the bottom. It also works the other way. The cosecant of theta is 1 over sine. So we have the cosine of theta will be 1 over secant, or the secant of theta is 1 over cosine. And we have the tangent of theta is 1 over cotangent, or the cotangent of theta is 1 over tangent. So there are 6 reciprocal identities. I'll put them here. And again, they are true by definition, by just the definitions of the 6 trig functions. All right, let's take a look at the quotient identities. So there are 2 quotient identities, tangent and cotangent. So we have the tangent of theta is sine theta over cosine theta. Why? Well, we have that the sine of theta is B over C. So let me put that in, actually. I have sine theta over cosine theta. So I have B over C. The cosine of theta is A over C. Dividing by a fraction is the same as multiplying by its reciprocal. So instead of dividing by A over C, you multiply by C over A. That's an algebraic property. The C's cancels. And I'm left with B over A, but B over A is tangent. So this is why it's true when you plug in your B over C and your A over C. And then our second quotient identity is cotangent of theta is cosine over sine. Why? You try it. Try to prove why cotangent is cosine over sine. And then we have 3 Pythagorean identities. So kind of the main one, and the one we're going to use the most, especially in the beginning of trigonometry, is that sine squared theta plus cosine squared theta is equal to 1. Okay, why? Again, let's plug in the definition. So sine theta is A over C squared. I'm sorry, not A over C, B over C. Plus cosine theta is A over C squared. In algebra, when it's divided, you can distribute the squared. So we get B squared over C squared plus A squared over C squared. They have a common denominator. B squared plus A squared is equal to C squared. I'm sorry, B squared plus A squared over C squared, but B squared plus A squared is equal to C squared by the Pythagorean theorem. So this little guy right here is the Pythagorean theorem. So we get C squared over C squared, which is 1. And this is why it's called the Pythagorean identity, because you prove it by using the Pythagorean theorem. So how do we get the other ones? Okay, well, the second one. So this is number 1. Number 2, divide by sine squared theta. So if I have sine squared theta plus cosine squared theta equals 1, I'm going to divide every term by sine squared. And I can do that because as long as I do something to the left-hand side of the equation and I do it to the right-hand side, it's fair game. So sine squared over sine squared is 1. Cosine squared over sine squared, well, if we go back to the quotient identities, cosine over sine is cotangent. So if it's squared, it's going to be cotangent squared. And 1 over sine squared, where if we go back to the reciprocal identities, on the right-hand side, 1 over sine is cosecant. So if I have 1 over sine squared, it's cosecant squared. So that's the second one. The third is instead of dividing by sine squared, we can divide by cosine squared. So we take our original 1, sine squared plus cosine squared theta equals 1, and we divide everything by cosine squared instead. Now, sine over cosine is tangent. That's the first quotient identity. So it's 2 of them, so it's going to be tangent squared. Cosine squared over cosine squared is 1. And then if we go back up to the reciprocal identities, 1 over cosine is secant. So because there's 2 of them, it's going to be secant squared theta. And here is our 3 Pythagorean identities. So if you know the main one, you can get the other 2. They come directly from the first one. Now, something I think I should have said before, and I apologize, is that what does that symbol mean? So sine squared theta means that you're taking sine theta and you're squaring it. Now, remember, sine theta is a ratio, right? You have an angle, it gives you back a ratio. So this means that you have 2 sines. You just have sine theta times sine theta. That's what squaring means. And so instead of using the parentheses with the squared, we use this notation. So we put the squared in between the sine theta, and it means sine squared theta. Okay, so let's use some of these. Okay, so we have given tangent of theta equals 1/2 theta acute. Find the 5 missing trig functions. So the first one we can find, if it requires very little amount of work, is going to be cotangent. Because cotangent of theta is the reciprocal of tangent, so it's going to be the reciprocal of 1/2, which is 2 over 1, which just gives me 2. For the other ones, I'm going to begin by doing a triangle. So I have here a right triangle, and then I use SOHCAHTOA. So it's important where I place my angle, because that's going to change opposite and adjacent. So I have that the tangent of theta is the opposite over the adjacent, which is 1/2. So the opposite is 1, the adjacent is 2. So by the Pythagorean theorem, I have 1 squared plus 2 squared is equal to c squared. 1 plus 4 is 5. So c is equal to the square root of 5, which is not reducible. So then I have that the sine of theta is the opposite over the hypotenuse. I need to rationalize that, so that will give me square root of 5 over 5. I have that the cosine of theta is adjacent over hypotenuse. Rationalize is 2 square root of 5 over 5. And then I can just use the reciprocal identities. So the cosecant of theta will be the reciprocal of sine, so it will be the square root of 5 over 1, which is just the square root of 5. And the secant of theta will be the square root of 5 over 2. So here are my 5 other trig functions. So now you can use some of the identities to solve these types of problems. All right, let's look at one more example. We want to find the exact value. So you're going to see these types of problems and this type of instruction a lot. So I wrote a little goal to help you remember what you're trying to do when you see these instruction, which again is going to be very common for the entire semester. Your goal is to simplify such that the trig functions cancel out or are evaluated. So we are going to be working with our golden angles, and that's going to come in the next few videos. But if it's not a golden angle, you can also play around with the identities. So if we look at the first one, 50 degrees is not a golden angle. So we're going to have to use some sort of identities to help things cancel out. So what I notice here is that what I can do is I can work with this part right here, the cosine of 50 minus sine of 50, and cosine over sine is cotangent. And because the angle is the same, I can use the identity. And so that will give me the cotangent of 50 degrees. So this will give me some sort of ratio. This will give me some sort of ratio but it will give me the same ratio, so it will end up being 0. And here's my final answer. Okay, let's take a look at the next one. So I have sine squared of pi over 12 minus. So 1 over secant is cosine. So 1 over secant squared is cosine squared. So I have cosine squared of pi over 12. And I'm sorry, this is supposed to be a plus. But sine squared plus cosine squared is 1. And again, the only reason that works is because these angles are the same. Okay? Otherwise, you couldn't. So by the Pythagorean theorem, the first Pythagorean identity, sine squared plus cosine squared of pi over 12 is 1. So in this one, we use the quotient identity first and then the Pythagorean identity. You'll see more of these in the next few videos.